make sure that when I do this subtraction, I need this to be times 10 to the 30th, because we cannot add or subtract, and we are subtracting unless they have the same power of 10. Once they have the same power of 10, then we can subtract. So in this case, I need to move this over 8 places. So when I'm taking a look at this, I'm going to have 8 places, means including the 1, I should have 7 zeros. So 1, 2, 3, 4, 5, 6, 7, 109. Now, if I take 2.03 minus 0.0000109, it's really close to what? Like if I was going to approximate it. What is it approximately equal to? 2.02999999, right? But that's almost. So even if these are, if I was looking at this and this is a 2 and then all these 9s behind it, 999, something like that, times 10 to the 30th. This is really almost the same as this, right? So what's the difference in their masses? There's really not much difference in their mass, right? Is what that's kind of trying to tell us when we do that subtraction. When you did the addition in question number 3, so if we are looking at addition or subtraction, I'd be willing to pick another addition or subtraction one that you want me to take a look at, that we could go through together to make sure you're understanding. I have 10 to the negative 5 and 10 to the negative 8. My larger power is 10 to the negative 5 or 10 to the negative 8. Which one is a larger number? The negative 5. So we are going to write down 7.45, if you haven't done this on your paper, leave some space, times 10 to the negative 5. That means this one must be 10 to the negative 5 also. So when you add and subtract, you must always have the same power. So if in this case I am adding these together, and this is 2.6 times 10, this is a negative 8. So this would make it, if I'm moving it, that's telling me that I had to move my decimal at this point 8 places. I don't want to move it 8, I only want to move it 5. So if I was thinking of moving it 5 places, I'm going to go back, that would be 7, 6, and 5, which means my decimal point with 1, 2 zeros, so 0.0026. These two numbers are the same number. Just one's written in scientific notation, and this one is kind of somewhat scientific notation, but not the same. So make sure you have this on your paper, please, on number 6, or on the top of the next page. So if I'm adding these, I'm adding 7 and 0, which is 7. 4 plus 0 is 4. 5 plus 0 is 5. 2, 6, and the power stays the same. So my answer when I add those two together, 7.4526 times 10 to the negative 5 is my answer in number 6. As I look at 7 or 8, which one should you take a look at? 7. The work I would look for is that you maybe put down 4.3 times 2.0. 4.3 times 2 is actually going to be 8.6. So if I'm looking at that, the second thing I'm going to be doing with this problem is I'm going to put the 10, it was 10 to the 8th power, times 10 to the 6th. Now, our rule of exponents that we just finished told us that when we are doing this problem, we multiply these two, which gives me the 8.6. And now I'm putting 10 and I add the 8 and 6. And 8 plus 6 gives me 10 to the 14. And this is in scientific notation, and I'm done with number 7. Now, if it's not in scientific notation, then sometimes you have to move that decimal point. If we look at 9 or 10, let's take a look at number 10. In number 10, first thing you're going to be thinking about is we need to take 8.1 and divide it by 9. Then we're going to do 10 to the negative 2. And then over in our denominator was 10 to the 2nd. On your calculator, or just thinking, 81 divided by 9 is 9, but this case it's going to be 0.9, so it's not in scientific notation. Now, when I do division, I have to subtract my exponent. So I am taking -2 minus 2, which is going to leave me with 10 to the -4. This is not in scientific notation. Our answers are always going to be in scientific. So this was telling me originally to move it 4 places. If I write my answer as 9.0, how many places now do I have to move the decimal? Not 4, but to get it here would be -5, as I am looking at that. Okay? Chris? Where it says many problems.
Many problems in math and science involve distance, speed, or rate, and time. This triangle is a shortcut to remember how those 3 items are related.
Want to keep going for me where it says many problems? Or keep that, find the distance?
Find the distance, given the speed and the time. Again, if you look at the formula triangle, you can see that you get distance by multiplying speed by time. Find the time given the speed and the distance. The formula triangle says that you get the time by dividing distance by speed. Find the speed given the distance and time. Looking at the formula triangle, you can work out that the speed is the distance divided by the time.
So when we take a look at these, when the question is asking you to find time, we're doing a division problem. Speed, also another division problem with our scientific notation. The only one where we're going to be doing multiplication, like we just did our multiplication, is when distance is equal to when you know the speed and the time. At the very top, it says I can choose the units appropriately for very small and large quantities. I can compare quantities using scientific notation, add, subtract, multiply, and divide if I am looking at those, and I can interpret scientific notations on calculators and computers as I'm looking at those. So if we are looking at this next problem, it says the speed of light is 3 times 10 to the 8 meters per second. The sun is 1.5 times 10 to the 11th meters from Earth. How many seconds does it take? So we're finding what? Time. Up above, what did it say time is always equal to? Distance divided by speed. Please write this on your paper. Time equals distance divided by speed. So the question says, how many seconds does it take sunlight to reach the Earth? Write your answer in the most appropriate form. And when we talk about appropriate form, it says normally we write numbers in standard or decimal form, but sometimes if they're very large or very small, we're going to write them in scientific notation. So in this case, what was our distance? How many meters distance are we talking about as I look at this one? What would you say, Cameron? The distance from these two numbers, which one am I putting down? Well, which one says meters behind it and not like a speed? Which one? Which one do we have, Mark? A little louder? Is that this is meters per second, and it says the sun is this many meters from Earth. So we have to decide which one is speed, how fast we're going, and which one is our distance. So I should be looking at distance being, say it one more time. The 1.5, please write down, times 10 to the 11th meters. That is my distance. So anytime we're looking at distance, it's going to be meters, miles, whatever we're looking at, okay? If I'm looking at that, that means then, as I'm looking at this one, live that my speed must be what? The other number, which is?
10 to the 8.
Well, we got to put the whole thing. We got to put 3 times 10 to the 8th, and this is going to be meters. So put your units per second. If we are looking at this is a division problem. So I'm going to do the division. If you have your calculators, some of you might know if we take 1.5 and divide it by 3. So what I need you to do is you have your calculator, take that out. Or if you want to do it in your head, I can do that too. 1.5 divided by 3 as I am looking at that. When you took 1.5 divided by 3, I don't think so. Should have been 0.5. So I divided that part, and now I have to divide with my exponents, which means, cousin, what am I doing with these two exponents when I divide? Subtracting. So I'm going to take 11 minus 8. So my answer came out to be 0.5 times 10, and in this case it was 10 to the third. Now, first off, this is in scientific notation, so if I want to write it in scientific notation, well, first off, standard form, how many places should I move my decimal? If I was asking you this on the quiz, 0.5 times 10 to the 3, if I wanted it in standard form, I would be looking, Autumn, at it being what number? How many places would I move it over? 3 places, which means 500. Does 500 seem like a good answer for writing how much time it's going to take? Saying 500 seconds? To me, that makes probably more sense than writing it in scientific notation as 5 times 10 to the second seconds. Why aren't I going to say 10 to the third? Because that's when it was 0.5. So if I move it over to be 5.0 scientific notation, this number must be between 1 and 10. To me, this answer makes more sense. On the test on Wednesday, I would probably take either one. But again, it's going to ask you to do it in the most appropriate form, which means which one do you think is best? And in this case, I think 500 seconds would be your best bet. As you take a look at that next page, as we are reading that next one, Jarrett, would you please read?
A newborn baby is about 2.6 times 10 to the power of 10 cells. An adult has about 1,900 times as many cells as a newborn. About how many cells does an adult have? Write your answer in most of them.
So if we're thinking of an adult cell, it says the adult is going to be the newborn times 1,900. 1,900 in scientific notation. Please write that right now. The newborn is already in scientific notation. 2.6 times 10 to the 10. You shouldn't need your calculator for this part. We're going to put the 1,900. What does it look like in scientific notation if I am looking at that? Ambry, what would you have? 1.9 times 10 to the third. So I'm going to be doing this multiplication. So as I am looking at this one, I'm going to take on my calculator and take the 2.6, and I'm going to write it that way, times 1.9. If we multiply those two together, I'm going to end up with how much? 4.94. Kira, we are also going to take our tens to the power. So I have 10 to the 10th times 10 to the third. What am I doing when I multiply with my exponents? Adding those. So in this case, this is how many, we were asked about how many cells does an adult have. We would say 4.94 times 10 to the 13th. This is probably a more appropriate way of writing this, rather than putting the 494 followed by how many zeros? Not 13, but this would have had 11 zeros behind it, right? This makes a lot more sense. 11 zeros behind that, that's a huge number, right? When we are taking a look at that. As we are looking at that next one, Brad, would you please read about population?
Population of North Dakota, 2004, 6.99. The population of the town of North Dakota that same year was 1.84 times. About how many times as great is the population of North Dakota as
Anytime you are finding times as great, what they are really telling you to do is to divide. And you're usually taking your larger divided by the smaller one. So in this case, if I was writing the population of Oaks, it is really like about 1,840, right? Standard form. We're going to take our larger one, the state of North Dakota. So we're going to take North Dakota, 6.99, almost 7, right? Times 10 to the 5th. And we are dividing it by 1.84 times 10 to the 3rd. Do the division on your calculator. So please do that right now. And subtract your exponents here and write that down. And that would come around. Yep, give me the two numbers after the decimal point. Started with what?
3.79.
3.79. Could I even round it to, could I leave it at 3.79 at this point? Yes. Could I go 3.8? I would take that also. Times, if we are looking at it, what should I have, Isabel? 10 to what power? 10 to the second. We're going to subtract those. And so this is about how many times greater is our population? We would say it's about 379 times. The state of North Dakota is 379 times greater than Oaks, right? So North Dakota is 379 times greater than the population of Oaks. Which, if you think about it, Oaks is a kind of a smaller town that we are looking at. Okay, let's go to that top of the next page as we are looking at these. We got a few more that we're going to look at. So, and the question is, how many kilometers are we looking at? Do we think we should add, subtract, multiply, or divide? If I am looking, 1 light year is this, and this is about this many light years. We should, when we think about a light year is that many light years from Earth. So when we are looking at this, how many kilometers? As you look at this one, we are actually going to take the 9.5 times 10 to the 12th times our light year. And that light year in scientific notation is 2.3 times 10 to the 6 times 10 to the 6. We are going to take on your calculator, please multiply your two numbers together. We are going to add our exponents for our numbers when we look at the power of 10. Jordan, did you get the first part when you multiplied? We have 21.85. And Carson, if we are adding our exponents of the 12 and 6, we should have times 10 to the 18. This is not in scientific notation. If you leave this answer on the test, I have to mark it wrong. The first number must be between 1 and 10. So when I am looking at this answer, I need 2.185. Now, I was supposed to move it 18 places to the right. Now I have to move it how many places? 19 or 17? Okay, so this was moving at 18 places. I put it back here. To get the same number, I have to move it one more place. That means 19, not 17. It's one more. To get it to look exactly the same, this one was trying to tell me to put 16 zeros behind it. This one, if I move it over 3 places, I'm still going to have 16 zeros behind it. So the grasshopper one, you're going to see one very similar to this on your test. If you were reading this one, Liv, want to read for us?
Sure. A scientist monitored a farmer's field to estimate the number of grasshoppers that were present. The researcher found that there were about 2.4 times 10 to the 6 grasshoppers in a 3-acre field. What is the density of the grasshopper population?
So when they say grasshopper population, the density means how many grasshoppers per acre. So we saw that story on CNN. I don't know if any of you saw that. But we're looking at a 3-acre field, 2.9 times 10 to the 6. So when we look at that, we're going to put our grasshoppers. Are there quite a few grasshoppers? Like, what does 10 to the 6 mean? That we're going to be looking at what number? How many zeros behind the 4? 5. So if I was looking at that, that's like 2,400,000 grasshoppers that we're talking about, right? So when they were talking about that infestation of grasshoppers in CNN, when any of you watch that with that. So if we're looking at 3 acres, how do we write 3 acres in scientific notation? 3 times 10 to what power? I want it times 1, right? What's 10 to what power is 1? 10 to the 0, right? That would give me times 1. So on your calculator, please take 2.4 and divide it by 3. 2.4 divided by 3 is going to give us a decimal, right? 24 divided by 3 is 8, so this is going to be, if I'm looking at that, 0.8 times 10 to the 6, right? 6 minus 0 is still 6. This was telling me to move it 8 places. In scientific notation, I'm really going to write it as 8 times 10 to what power? Okay, this was telling me to move it over 6 places. If I put the decimal here, do I have to move it as far? No, I have to move it 1 less. So my answer would be 8 times 10 to the 5th. Now, at this point on the test, you didn't want to write it in scientific notation. Could you simply tell me how many grasshoppers that means that we're going to have, so that I could see on your paper that you're just going to write that as 80, if we are looking at it, 800,000 grasshoppers, and you're going to want to make sure you put that label with it. So notice that we say per acre as we are looking at it. Could you have had this answer, 8 times 10 to the 5th? Yes, but if you're telling someone how many grasshoppers there are, and you're going out in public and you're saying it, and you say 8 times 10 to the 5th, this probably wouldn't be as appropriate, right? Because most people are kind of like, what do you mean? How many is that? Is it 80,000? Is it 8,000? Is it 8 million? So knowing the 800,000 as you are looking at that. There are 2 more problems on this page. This one deals with social networking site. It says there was 200 registered accounts in 2011, and in August the same year that increased to 3.62 times 10 to the 8th. So we went from 200 million to this. So our numbers are written in different ways. So the key thing here is we need to understand, what does 200 million look like? And it says how many more? What operation are you thinking for how many more? That we should do what? How many more? Add, subtract, multiply, divide. What are you thinking? Does it make sense to subtract how many more? Just subtract them. It's not how many times more, just how many more. So the first thing I want you to do is write down 200 million. 200 million looks like, in standard form, 200, right? With 6 more zeros behind it. Isn't that what 200 million looks like, right? So think about what it looks like when you're on the test. That means 2 times 10 to the 3, 6, 8. These 3 things are exactly the same way of writing that one number. It's just depending on what you're doing with it, okay? Then we have this one of 3.62 times 10 to the 7th. Well, this was the new users in August, so we are really taking August, right? And you're going to subtract the number of people that were using it in April. So this is simply a subtraction problem. 3.62 times 10 to the 8th, subtracting 2. How nice that they have the same power for our value of 10 to the power. So 3 minus 2 gives us 1.62 times 10 to the 8th. They have a video with this one and the next one. I think I'm going to go through the 2 problems with you just to make sure that as you are looking at these that you're understanding them. And I will attach those videos on the daily planner if you want to take a look at them. So this next one, if we are reading this, Jordan, would you please read?
The mass of the Earth is 5.97 times 10 to the 24 kilogram. Mass of the Moon is 7.34 times 10 to the 22nd kilogram. What is the combined mass of the Earth and the Moon? Put your answer in the most appropriate form.
So if we're looking at combined mass, we would think we should add. They are not to the same power, right? So we got to change the 10 to the 22nd to be the same one. So we're going to start with 5.97, and I'm going to put times 10 to the 24. Why do I want to leave room? Because I need to make sure that this 10 to the 22, which meant to move my decimal 22 places, that now I have to move it 24 places, right? So I want to change the 22 to a 24. If I'm gonna move it 24 places, that's gonna be 23, 24. That means I'm gonna have 0.0734. And I am adding these. I can only add when the power back here is exactly the same. So now if I am adding these, I'm gonna start with adding in the back here if I'm adding those together. So the 4, 7 and 3 gives us 10, we carry that, right? 9 and 1 gives us another, if we are looking at that, did I set that up right? 9, 7, my fault here. Lining up place value is gonna be helpful for you also, just like I did. So we have 2 zeros behind here. So the 4, then we have 3, 7 plus 7 gives us 14, 9 and 1 gives us 0. This is going to now give us 10, so 6.034. 34, if we are looking at it, times 10 to the 24. Our label would be kilograms. I do not want to see on your paper that written in standard form on the test. I do not want to have to try and count that there are 19 zeros behind this, correct? I'm not going to count that many zeros. That's a hard number to count. Some of you are going to make a mistake and put 18 instead of 19, or you'll put 20. So you leave this answer. This next question says, if we are looking at it, how many times as great is that mass? Well, now we want to take the 5.97 and we are going to divide it by the 7.34. So take those calculators, you're going to be dividing by 10 to the 22nd. This one I would take in standard form, right? Why? 5.97 divided by 7.34 comes out to be about what? 0.81 times 10. What are we doing with these two exponents when we divide? Subtract, so 10 to the second. I don't want to leave my answer like that. That's about how many times? How could I write that in standard form? It should be about 81, right? Doesn't 81 times greater look better than 0.81 times 10 to the second? So when you look at the problems, you kind of have to think about which way you're going to write each of those.